Section 9.1, Finding Formulas for Inverses. We've just looked at determining whether a function is one-to-one by graphing it and then performing the horizontal line test. Another method is to find the inverse. If it's possible to solve uniquely for y after x and y have been interchanged, then the function is one-to-one. So how do we find the inverse? In f to the negative 1, this is not an exponent, it's the notation for the inverse. So to find a formula for the inverse function, they have a little note here to make sure that it is one-to-one, and by looking at a graph we can determine that. But our first step is to replace the function notation with y. Next, we want to switch x and y. Y becomes x and x becomes y. Third step is to solve for y and then finish it off by replacing y with the inverse function notation. So let's take a look at an example. They're asking us to find the inverse function, if possible, of the following. If we aren't certain whether a function is one-to-one, we can try to find a formula for its inverse. If it's possible to solve uniquely for y after x and y have been interchanged, then the function's one-to-one. So let's try that. The first step says replace your function notation with y. Next, switch x and y. We have a problem. There isn't an x in this formula. So it may not be obvious, but because we can't solve uniquely for y after x and y have been interchanged, because there is no x, this is not possible. And to help you understand this, let's graph y equals -3. What does the line look like with the equation y equals -3? All of the y values in the points on this graph are -3 with the ever-changing x. That means we have this horizontal line which is representing the equation y equals -3. And clearly, when we do the horizontal line test, it's intersecting an infinite number of points and would fail the one-to-one method of using the horizontal line test to determine whether a function is one-to-one. If it fails the horizontal line test, it's not one-to-one and it's not possible to determine the inverse function. In this next problem, we could graph this and visually determine whether it passes the horizontal line test. And don't let the fraction throw you off. We could call this 4/3 x minus 5/3. This is a linear equation which is going to pass the horizontal line test. So let's get to it, find the inverse function. First step is replace the function notation with y. The next step is to switch x and y. So x becomes y and y becomes x. The next step is to solve for y. So to get rid of the denominator, we'll multiply both sides by 3. We have 3x is equal to 4y minus 5. To undo a subtraction, we add. So we'll add a 5 to both sides. 3x plus 5 is equal to 4y. And last, to get y by itself, divide both sides by 4. We now have 3x plus 5 over 4 is equal to y. Last step, replace y with the inverse function notation. And because we were able to uniquely solve for y after x and y have been interchanged, this is a one-to-one function, and we have the inverse defined as 3x plus 5 over 4. In this next example, we have the cube root of x plus y. And it may take a little bit to graph this, do the horizontal line test to determine whether it has an inverse or not, because it is a one-to-one function. The other option is simply to try and find the inverse. So let's go that route again on this problem, replacing the function notation in the first step with y. Next, we will replace x and y. Third step is to solve for y, and to undo a cube root, we will raise each side to the third power. X to the third power is that. Cube root of anything raised to the third power, because you would have y plus 9 to the 3 over 3 when you take your index and put it as the denominator of your exponential power. Those cancel out, leaving y plus 9. And to solve for y, we'll subtract a 9 from each side, which is leaving us y uniquely solved in terms of x after switching the two. So this was a success finding the inverse, and the only thing left then is to use the inverse notation for our solution. This original function is a one-to-one because we have its inverse.